So we need to prove the following. So let's begin from the left hand side. So here we have 2 times secant squared theta minus we have secant theta whole raised to the power of 4, which can be also expressed as secant squared theta whole squared, minus 2 times cosecant squared theta, and cosecant theta whole raised to the power of 4 can be also expressed as cosecant squared theta whole squared. The reason why we've written in this fashion, because in place of secant squared theta, we can replace it with secant identity 1 plus tangent squared theta. And we have another identity which states that whenever we have cosecant squared theta, that's equivalent to 1 plus cotangent squared theta. So in place of secant squared theta, we'll replace with 1 plus tangent squared theta, and in place of cosecant squared theta, we'll replace it with 1 plus cotangent squared theta. So we'll do this with this secant squared as well. So we have 2 multiplied to 1 plus tangent squared theta minus, so we have 1 plus tangent squared theta whole squared, minus 2 times cosecant squared theta, so that's 1 plus cotangent squared theta, plus cosecant squared theta, so that is 1 plus cotangent squared theta whole squared, which will be equals to, so we have 2 plus 2 times tangent squared theta minus 1 plus tangent squared theta whole squared. So we can expand it using the identity a plus b whole squared. So we have a squared plus 2ab plus b squared. So that will be b squared will be tangent theta whole raised to the power of 4 minus 2 times cotangent squared theta, and we can expand 1 plus cotangent squared theta whole squared as 1 plus 2 times cotangent squared theta plus cotangent of theta whole raised to the power of 4. Right. So let's further simplify this. So we have 2. So here we can cancel out this 2 and this particular 2. So we have 2 times tangent squared theta minus 1 minus 2 times tangent squared theta minus tangent theta whole raised to the power of 4. Then we have negative 2 times cotangent squared theta plus 1 plus 2 times cotangent squared theta plus cotangent theta raised to the power of 4. So 2 times tangent squared theta and negative 2 times tangent of theta cancels out, positive 1, negative 1, and we have negative 2 times cotangent squared theta and positive times 2 tangent cotangent squared theta cancelling out, and we are left with cotangent of theta raised to the power of 4 minus tangent of theta raised to the power of 4. Now we know that the cotangent function, that's the reciprocal of our tangent function. That means cotangent of theta, it's equals to 1 over tangent of theta, which means cotangent of theta whole raised to the power of 4, this can be expressed as 1 over tangent of theta whole raised to the power of 4 minus tangent of theta raised to the power of 4. We can combine the two terms, and that will be equals to 1 minus tangent of theta whole raised to the power of 8 whole divided by tangent of theta raised to the power of 4. And this is the expression on the right hand side. Hence we have successfully shown that the left hand side is equals to the right hand side, hence proved.